Okay, Assalamualaikum and good day everyone. So now we have come to the next chapter, which is alkenes. What is alkene actually? So alkene is unsaturated hydrocarbon. Okay, the only saturated hydrocarbon that we have learned, okay, previously is alkene. Alkene. So now we learn about alkene. So alkene is about carbon-carbon double bond, which is the functional group of the alkenes. Okay, so it consists of multiple bond. Okay, double bond. So the general formula of alkene is CnH2n, and the number of carbon atom or the number of n actually must be equal or greater than 2. Okay, so then only we will have alkene. So alkene will start with ethene to carbon. Okay, then the functional group of alkene is carbon-carbon double bond. Then it is an unsaturated hydrocarbon, which you will learn okay, mainly in the type of reaction lah. Okay, the type of reaction for alkene is addition reaction because it consists of carbon-carbon double bond. Okay, unsaturated. So each carbon atom of carbon-carbon double bond is sp2 hybridized. Okay, so it consists of one sigma and one pi. So when it consists of carbon double bond, it is sp2 hybridized, which you have learned previously in semester 1. Okay, so next is the restricted rotation of the carbon-carbon double bond causes cis-trans isomerism. Okay, this is one of the characteristic of cis-trans isomerism, which is the restricted rotation about the carbon-carbon double bond in alkene. Okay, so the first characteristic of the cis-trans isomerism. Okay, the alkenes IUPAC names will have the in suffix. Okay, in suffix, it will end with ene. Okay, so few steps to determine or to come up with the nomenclature. IUPAC nomenclature of the alkene. Okay, as usual, step 1, you should determine, okay, the parent chain with the longest chain that contains the double bond. So first you need to find the longest chain, and the longest chain must include the carbon-carbon double bond. Okay, and then the parent chain is okay. Okay, the ending of A and E is changed to E and E. Okay, from alkene to alkene. Okay, and then step 2, the carbon atoms in the double bond must have the lowest possible number. So let's have a look at these two examples. Okay, the example at the left side, we have okay, the same structure of at left and right side. At my left and right side. Okay, at left side, we will start numbering, or the longest chain is numbered in green colored. Okay, is highlighted, okay, in green color. Okay, so then it is numbered. Okay, it consists of 6 carbon, but there is no carbon double bond included in the parent chain. Okay, then if you want to include the parent chain with carbon-carbon double bonds, it will only consist of 5 carbon atom. Okay, 5 carbon atom, and then we will start numbering lah. Okay, so we will start numbering. Okay, the carbon atom. Okay, from the side with lowest possible number of the carbon atom. Okay, to give the nomenclature lah, the correct names. All right, so 1, 2, 3, 4, and 5, only 5 carbon atom here. And at carbon number 2, there is the functional group. Okay, the functional group is ethyl of 2 carbon. Okay, 2 ethyl. So the parent is 1 pentene. Okay, so the correct IUPAC nomenclature is 2 ethyl 1 pentene. Okay, and then for step 3, okay, we need to indicate the position of the substituent by the number of the carbon atoms to which they are attached. Okay, so the lowest number of carbon-carbon double bond is at carbon number 2, okay, 2 or 3 lah. Okay, so it depends on how you numbered, okay, the carbon atom. Okay, but which one is the correct one? Okay, and the lowest number of the substituent of the carbon-carbon double bond has the same number. Okay, so okay, which one do we prefer? Okay, so from the left side, okay, carbon double bond is at carbon number 2 with the substituent methyl. Okay, and at my right side, if we numbered from right side, carbon double bond is at carbon number 2, but okay, the substituent is at carbon number 3. Therefore, which one do we prefer? We will prefer the nomenclature or the IUPAC name which has the smallest number of carbon atom. Okay, so this one will be 2-methyl 2-butene, and we compare it with 3-methyl 2-butene. So we will prefer 2-methyl 2-butene. Okay, then for the nomenclature or the structure, okay, that have 2 or 3 carbon-carbon double bond. So we will represent, okay, the number of alkene, okay, or carbon-carbon double bond with di if there is 2 double bond, and tri if there are 3 double bond. Okay, for example, for the first structure, okay, the top one. Okay, so we have 4 carbon atom with 2 carbon-carbon double bond, and carbon-carbon double bond is at carbon number 1 and at carbon number 3. Okay, therefore the nomenclature will be 1,3-butadiene. Okay, for the next structure, okay, so we have 3 double bond. Okay, 3 double bond, and the double bond is at carbon number 1. Okay, so note that we start numbering from the right side because it will give the lowest possible number of carbon atom. Carbon number 1 will consist of carbon-carbon double bond. Okay, if we start numbering from left side, you will have carbon-carbon double bond at carbon number 2. So we will prefer we will start numbering from the right side. So the name or the nomenclature will be 1, 3, okay, 1, because the carbon double bond is at carbon number 1. Okay, carbon double bond is at carbon number 1, carbon number 3, and at carbon number 6. Okay, since there are 3 double bonds, so it will be we call as 136 octatriene. All right. For step 5, for the cycloalkene, okay, the carbon double bond in the alkene, cycloalkene, must be numbered, okay, as number 1 and number 2. Then we will follow, either we want to choose clockwise or anti-clockwise, okay, depends, okay, on the position or the number of the substituent, the position of the substituent, so that it has the smallest number of carbon. Okay, For example, we have the structure, carbon 1 and carbon 2 must be the alkene, carbon double bond, and carbon number 1 also will have one substituent, okay, one substituent, which is the methyl. So the nomenclature will be 1-methyl cyclopentene. So we don't have to give numbers for double bond. Okay, if it is only one double bond in the cyclic compound, so you don't have to give the number for double bond. Okay, for carbon double bond, okay, for the right side structure, okay, so we have 5 carbon atom also, and the carbon number 1 and 2 is numbered as carbon number 1 and 2 is start for the carbon double bond. Okay, then clockwise, okay, clockwise direction. Number 3 have one substituent, and carbon 4 also has one substituent. Okay, therefore the name, okay, the nomenclature that you will give, okay, you will name it as 3,4-dimethyl 1-cyclopentene. Okay, so this is the nomenclature. Then we also have other other numbering, another way to number the carbon, so that carbon number 1, so here carbon number 1 start from here, then carbon number 2 clockwise, 3, 4 and 5. Okay, so carbon number 1 and carbon number 5. Okay, supposed to be if you name your structure 1 and 5 here, you number it as 1 and 5, you will get as 2,3-dimethyl 1-cyclopentene. Okay, so 1-cyclopentene. So this one is not, this is wrong. Okay, we say this is wrong because carbon 1 and 2, the double carbon double bond must at carbon number 1 and at carbon number 2. Okay, so means that we prefer this one. Okay, we prefer this one and exclude. Okay, exclude 1 here. Okay, 1, there is no 1. Just combine together. Okay, so the nomenclature will be 3,4-dimethyl cyclopentene. Okay, cyclopentene. Okay, so this one is correct. Okay, so exclude the number 1 here. Maybe if you refer to internet or some notes, there is they include the number 1. Okay, but normally we exclude number 1. All right. Okay, for step 6, if there is substituent, substituent that is consists of carbon double bond, that is called as alkene group, which is the vinyl and allyl. Okay, vinyl consists of 2 carbon atom and allyl consists of 3 carbon atom of the substituent. Okay, vinyl, 2 carbon atom of the substituent, and you have the alkene, okay, alkene as the substituent, alkene of 2 carbon, okay, and allyl, alkene of 3 carbon as a substituent. Okay, for example, we have the parent of 1, 2, 3, 4, 5, 6, okay, 6 carbon atom. Okay, 6 carbon atom, and the substituent is at carbon number 3. So carbon number 3, there is consists of 2 carbon atom, which is alkene, substituent alkene. So it is called as vinyl. Okay, so 3 vinyl, 1 for, okay, 1 for dipentene. Okay, dipentene. Okay, 3 vinyl, 1 for pentadiene. Okay, so I missed the penta just now. Okay, pentadiene. Okay, 5 carbon atom. Okay, 5 carbon atom. All right. So when two identical groups are attached to the carbon-carbon double bond, and it has the structure as given, as shown, which means that this is in a three-dimensional structure lah. Okay, so in three-dimensional structure, means that it is not in CH2 double bond CH3. So this one is two-dimensional. So this one is 2D. Okay, 2D. So this is 3D. Okay, 3D. And we can see that the position of the hydrogen group, okay, the hydrogen atom, okay, the hydrogen atom is at the same site. Okay, same site means that this is the cis isomer. Okay, cis isomer, and we check, okay, the parent chain consists of 1, 2, 3, 4, okay, 5 carbon atoms, and double bond is at carbon number 2, okay, carbon number 2. Okay, carbon number 2, therefore the nomenclature will be as 2-pentene, okay, 2-pentene, and because of the same side of hydrogen atom, cis-2-pentene, okay. Next structure at my right side, we have 4 carbon atoms, and we start numbering either from the top or from the bottom, since it's the same, but the position of hydrogen atom is at opposite side. So when it is at opposite side, therefore the nomenclature we start with trans to butene. Okay, so trans to butene. I think that's all for nomenclature of alkene. So I'll see you in the next lecture of alkene, which is reaction of alkene. Okay, with that, thank you and Assalamualaikum.